Session we'll be talking about physics and rigid body in Unity. Physics in Unity is handled by built-in physics engine. Unity's built-in physics engine runs the physics for game object interactions and various effects such as gravity, acceleration, collisions, etc. Unity simulates physics to ensure that the objects correctly accelerate and respond to the collisions, gravity, and various other forces. To have convincing physical behavior, an object in a game must accelerate correctly and be affected by collisions, gravity, and other forces. Unity's built-in physics engine provides components that handle the physical simulation for you that behave passively in a realistic way. There are two separate physics engines in Unity, one for 3D physics and one for 2D physics. The main concepts are identical between the two engines, but their implementation is different. For example, there is rigid body component for 3D physics and rigid 2D component for 2D physics. Let's talk about rigid body in Unity now. Rigid body in Unity allows a game object to have physical behavior. It will interact with other game objects. The Unity physics engine only knows that an object is meant to be acted on by the physics if the rigid body component is attached to the game object. Properties of a rigid body: mass, drag, angular drag, use gravity, is kinematic, interpolate, collision detection, and constraints. Let's see one by one what does these properties mean. Okay, let's talk about mass here. Mass is the mass of the game object. Drag is the air resistance value applied to the game object. Angular drag is the air resistance value affecting the rotation of the object. Is kinematic. If enabled, object will not be affected by physics engine in Unity. Interpolate. It is used to smoothen the movement of the object. Collision detection. It changes the type of collision detection on the object. Constraints. Freezes movement and rotation on certain axis of the game object. So that's it, guys. Thank you for the session.